before we get to the graphing calculators today, what you've been doing so far is trying to find basically just rational factors is what you've been trying to find. And what rational factors will tell you if you set them equal to 0 is where that particular graph that you started with will hit the x-axis. Okay, those are called zeros, right? And so if you take a look at our graph A here, basically the 0 is all the places that it hits the x-axis. So if we look at this one has how many places? Well, it hits there, there, and there. And according to those arrows that are going that way and that way, you know, that's it, right? They're telling me that it just keeps going. It will not come back. And if you remember, that's kind of that, we called that an odd function earlier in this chapter, right? One ending in one direction, one ending in the other. And I would say how many zeros? Well, there are 3. And just to help you out a little bit, that is a fairly common graph of x to the third. Okay. Not all x to the third graphs do that, but again, if it is x to the third, it has 3 possibilities of hitting the x-axis. They don't all have to, but it can. So how many does letter B have? 2. Now that we called an even function earlier, right? Because they end in the same direction. And, oh, look at that. It has 2 zeros. Kind of weird. And I think we've all seen, we know that's kind of a parabola, right? And parabolas come from, you know, it could be x squared, could be x to the 4th. That's where the even ones have more fun, I guess you could say. That's a very common graph for x squared. Okay. This one here, how many zeros does that one have? Well, this particular one only has 2, correct? And you're going to learn that that can't possibly be x squared. Because you see how I could very easily, and maybe if I just ungroup them, I don't know. I might really mess things up here in a second, but that's all right. I could easily move this one. Oh yeah, it's one picture, so I can't. Do you see how I could move these W's down and have it do something like that? Do you agree I could just slide the graph down and that's what it could do? And then how many times would that one hit? That would hit 4 times, correct? So that would be x to the 4th. But the one that we have, yeah, just because it has 2 doesn't necessarily mean it's x squared, because it probably is still x to the 4th because it has the extra hills and valleys in it. Okay. But the key here for right now is to know that if it hits there and there, how many times does it hit? Twice. Okay. That's how many zeros it has. Okay. So any questions on that? Well, it'd be really nice if we knew where that happened. Right? If we could figure out where that happened. And that's what we're going to do on this next one. I'm going to show you a few features here, and I'm going to write it on the whiteboard so that I can bring up the graphing calculator. So x to the third plus 3x squared minus 2x minus 5. Okay, well, let's take a look. Whenever you turn on your graphing calculator, it should come to a screen something similar to this with a little blinking cursor on there. There may be stuff on there, you can just clear it off. One thing you're always going to want to do, because somebody in another class that used this may have used different settings, or maybe they just wanted to mess with you a little bit and they just put weird settings on there, all right? And so you might want to check. Yours will be a little bit different. I don't think a lot of you will have this bottom one. I think those of you with the 84 will still have that bottom one on there. But the 83 has all the other ones. And for what we're doing right now, it's pretty standard that you just want everything on the left-hand side, because options go left to right. For example, that's another option that's scientific. Okay, that would put everything in scientific notation. I don't think we want that, all right? So if you need to, all you do is have to highlight the option you want. Again, they go left to right, your options, and say, okay, enter, that's the one I want. Okay? So what you might want to do right now is go through and make sure they're all on the left. Some are more important than others. Okay? Now you have to get out of there, and probably the easiest way to do that is to use the quit button, which is right above mode. Right? So you have the blue button first, and then mode. And I think for you on the 83, it's like what, a peach colored, the second key is kind of orange or peach or whatever that is to get out of there. So what we want to do is we want to graph this, and we have been given something that is y equals a bunch of stuff, correct? And we'd like to enter that bunch of stuff. So what button makes most sense to hit? Which one is going to be helpful is y equals, because then you can put in your bunch of stuff. And y equals is this one on the top left right there. Once again, you may have a bunch of stuff in there, and all you have to do is clear out the stuff you don't want. So, maybe somebody had just, a bunch of stuff just sitting in there. Who knows? X, cosine, who knows? All right, and you want to get rid of that, just go ahead, hit clear. It should go away. All right? And on these, the variable button is this one right here. And I believe it's in the exact same location on the 83, right? Yep. Next to the alpha button, just to the right of the alpha one. And every time you hit that, well, X, there it is. Now you have to get the third power. Well, there's a couple ways you can get the third power, but the quickest way, just from this setup, is to use the caret key, which is a little house-looking thing. And then type the 3. So that's X to the third. Plus 3. We need the X again. No, it's still in the same place. It's still right there. Could you do caret 2? Is that okay? Yep. But Texas Instrument knew that squaring was going to be something that you're going to do a lot. Let's face it, Algebra 2, you spent how long doing stuff that was X squared, right? So they knew it was going to happen a lot, so they actually made it its own button. But it doesn't give you the X and the square, it just gives you the square. Okay, you ever see that? It won't give you the X and the square on it, it'll just give you the square. Minus 2. Again, you have to hit the X every time you need it. And then notice which minus I'm hitting. I'm not hitting the white one down there. I'm in this one that's actually the operation. Minus 5. So does it look as though I have that function in there properly? Do you believe you have the function in there properly is the next question. Okay? Now, we are going to take a look at this graph, but it's very possible that every single one of us can hit the same button next and get a picture that looks completely different. Does that mean any of our pictures are wrong? No, these have settings. You can zoom in, you can zoom out, you can make X and Y, min and max, all these different things. So what I like to do from this point, so that we all get the same thing, because obviously you could hit graph right now and we would all have it graphed. But if you hit zoom and then go to standard, then we should all have the same picture. And you can either scroll down to zoom standard, or seeing it as the 6th option, you can just hit the number 6. Okay. So any questions so far? Now I know many of you, you're starting to see these calculators a little bit more, right? So what you just saw today, maybe not the hardest thing in the world for you, right? You've seen some of it before, you remember it, right? So we're going to show you more. You remember all those times when you were graphing lines, we asked you to make a XY table, right? Sometimes it took a long time. Sometimes it didn't. Well, the beautiful part about this is it had to get those points from somewhere. It just didn't make them up, right? So it's actually already done that. You just have to tell it how you would like it displayed. So is everybody ready for this one? Pay attention. If you get lost, this is going to be painful. Right up here above window, it says table set, right? So hit the blue, or for you, it's that peach color, whatever you want to call it. Second, and table set. Well, it's asking me, where would you like the table to start? Well, a lot of people like to just choose 0. But that's okay. It's not going to hurt you all that bad. But where was a lot of our graph? Wasn't it kind of like -4, -5, somewhere around in there? Wasn't that kind of where the graph started? So why don't we try that? Now, for this negative, you should do negative and then 5. The beautiful part is if you mess up the table start, it doesn't even matter. You can still scroll to whatever you want. I can put in -1,000 right now, and I can just scroll to the ones I need. Now, here's something that I know you've seen, this little triangle thing, and that is the Greek letter delta, which stands for, many of you have said that already, change. So how do you want your table to change? Is going up by 1, isn't that normally how we make a table? Yeah, so let's just leave it at 1. And the beautiful part is if you want a smaller number, like 0.1, would you ever make an XY table that went up by 0.1? No. But if the calculator is going to do it, who cares? You know, let it do it. It'll do it. But I think 1's good enough for us. So leave those on auto. Don't mess with those. So now you see this one above graph. It just says table. So what you can do then is hit second and graph, and there's your XY table. And what I meant by scrolling up and down, if you use the up and down arrows, you can maybe go get one of them. Maybe you just chose a bad starting spot. Well, you can go up, or you just got to go all the way down here. And mine does hesitate a little bit. It's okay. Or go down and go get some more values. Okay. So maybe just get a few values there so that you can make a pretty accurate graph. So what do we got there? Well, -4, -13 is not going to fit on your graph very well, but get it close. To get a semi-accurate graph, all right? Get a sketch in there. Yeah, I don't think that one's going to fit. And 211. That was pretty easy just to write that down, right? I mean, that took me, what, a second just to copy those numbers down? or just plot those points and get a pretty good sketch of your graph. Okay? I'll give you a second to do that, and then we'll go and do the next thing I'm going to show you today. When you were in Algebra 2, because graphing this was so new to you, basically I decided a few years back that I was not going to show you this next little tool. But now that you've graphed it, you've seen this before, some of you may have even seen that table thing before, I'm going to show you, because here's what we used to do, right? To find zeros, you just keep hitting that thing until it got close, right? Oh, 1.3. Right? Isn't that how you were taught how to do it before? And then you'd move it over until it got close and say, oh, that zero is negative 1.1, right? Isn't that what we did in class? That's how you were taught to do that in Algebra 2? Well, believe it or not, this calculator is way more powerful than that. All right? It can actually just calculate it for you. And basically, if I want to calculate something, well, do you agree this is pretty much your graphing menu up here, kind of? Right there, C-A-L-C, calculate. Those are the types of things that you can calculate on your graph. You can calculate a value, you can calculate a zero, a minimum, a maximum, an intersection if you had two lines. That might come in handy when you do systems of equations. That is calculus, that's derivative, that's antiderivative. So yes, these can do calculus. Right? Well, based on what the words I've been using today, which one are we probably most concerned about today? Zero. So again, you can either scroll down to zero, hit the 2, whatever it is you want to do. It always gives the y-intercept when it goes for zeros. I don't know why it does. It must be a default in the program. Okay, so now look what it's asking. Is everybody caught up? Let me know if I went too fast. It's asking for a left bound. So let's say we all want to go and try and find this one. So just kind of go to the right a little bit and get something that's kind of close, but make sure that as far as x values are concerned, you stay to the left of it. Do you agree that this is where it is and I'm a little to the left of that right now? That this is actually where it is right along here, and I'm a little to the left of it. You agree? That's all the closer you have to get. You don't have to get right in there. Just something that is to the left. Okay, everybody got something that's kind of to the left? It doesn't have to be exactly the same one I have, but you got something close? Then go ahead, hit enter. Now what's it asking for? And do you notice I put a little arrow up there? That's your left bound. It figured that out, all right? It marked it. Well, right bound, that means go to the right of it. So get a little bit. Is that technically to the right of where my zero is? It's right here. Is that technically to the right of it? Yeah. So that's a good right bound. So I should probably hit enter. Now it's asking for a guess. Say, I don't know, right about there. That's about right, isn't it? See, all I did, I just got something close. A lot of times for the guess, you don't even really have to do anything. But I just got something that was close. And once you hit enter, it's just going to give you the answer. 1.3300587. Accurate to 7 decimal places. So let's go and throw that one on the ground. We'll just say for us 1.33. Okay, we don't have to write all that stuff. Yeah, I'm kind of lazy. So now that's only one of them. So we have to start the process over. How do we start this thing again? You don't have to graph it all again. I'm saying how to get a zero. Where did we go? Yeah, so second, calculate. And which one do you want again? The second one. Now, is that a good left bound stay for this one? No, that's terrible. That's way to the right of it. So I get back over there. So if this is my 0, is that to the left of my 0? Yeah, some of you may have left it down here. That's below your 0. I agree with that, but it's actually to the right of it. Okay, so this is to the left of my 0. Again, it marks it. See, it marked it. Get something to the right of it. I would probably do that. Again, if this is my 0, that's to the right of it. Again, I'm pretty sure you can just do nothing with the guess and it'll still work. But I like to just get it close just to make sure. So negative 1.20164. And seeing that terminates like that, because the other one went out a little further, I'm guessing that's pretty much dead on. Okay. So negative 1.20. And why don't you go find that third one right now? Yeah, you got to kind of start the process over. Okay, you notice up here, I love it when it does that. Oh well. I made my left bound way over here, my right bound way over there. I made a really wide range this time, just to show you that it's still going to work. It really doesn't make a difference. And a lot of times with that guess, you don't even have to get that any closer either. That's for something else. Go ahead, I got negative 3.128419. So negative 3.13, we'll say. So I think you can agree these answers are much more accurate than the answers you were guesstimating in Algebra 2. Once you get used to it, it goes a lot faster, but it does take a few more buttons to push right now, but it's much more accurate. Okay? And you notice that this function was x to the third, and it hit 3 times. That's the max it can hit. If you have an x to the third that you graph and it hits 4 times, you might want to reset your calculator. Any questions? Okay.